Hi, we'd like to welcome you to another in a series of webinars designed for departments of transportation. I'm Terry Bills, and I'm the Transportation Industry Manager here at ESRI. And today I'm joined by Don Keeney, who's the ESRI 3D Product Manager of CAD, BIM, and AEC. Today's webinar is focused on the future of 3D and transportation. And more specifically, how can we begin to think about the integration of data and information between GIS and CAD and BIM, or civil integrated management? As long as I've been attending the GIST symposiums, the issue of CAD and GIS integration has always been one of the central issues that the GIS managers at the state DOTs were concerned with. There was a strong desire on the part of the design engineers to be able to use GIS data as part of their design process. And similarly, there was a desire to be able to use as-built as a way of updating our GIS files. And now increasingly our design processes are moving into a 3D environment, and the ability to take advantage of GIS in that process is becoming even more critical. So we would like to start the discussion of how that is going to change the way that we do things, and begin to discuss both how we at ESRI are responding to this trend and how we can help those in the transportation community more easily respond to those changes. So there really are a series of issues. First, how is the move to 3D going to change the way that we plan and design and construct our transportation infrastructure? Secondly, how will we be able to integrate data between these different data formats? And how will we manage these disparate data types to more effectively support the rapidly changing transportation and infrastructure processes? This is really just the start of what will likely be an ongoing discussion and an issue of growing importance to us all. And additionally, the slides which are part of this webinar will be available to you on the GeoNet group Departments of Transportation, and we'll give you a link at the end of the webinar. So many of you have certainly seen this slide before, or at least one like it. And we often speak of the transportation infrastructure lifecycle, from planning through design, operations, and maintenance. And the point of showing this slide here is that I think the real goal that most of us in the transportation community would like to achieve is how do we integrate information at each stage of the infrastructure lifecycle in such a way that we can have a seamless transition of data and information as we move through the process. And this doesn't mean that GIS is the only technology involved. Rather, I think we need to understand that we'll have a number of technologies that are brought to bear throughout this life cycle. We need to be able to think about integration and ultimately interoperability between these various technologies if we're going to do a better job at planning, delivering, and preserving our infrastructure. And this slide presents the standard division of labor between CAD and GIS technologies, or CAD and BIM or SIM. While there are always overlaps at the margins or the intersection of these stages, I think we can all agree that we typically begin the planning process in GIS, increasingly move into CAD or BIM and SIM as we move through the design and construction, and then back into GIS when we move to operations and maintenance. But increasingly, we also want to be able to move between these technologies at each stage as well. So if I'm a design engineer, I may want to bring in imagery into my design environment, or elevation or environmental data from the GIS. And conversely, during maintenance, I may want to access my original design files, but I want to access them through the GIS. So I think the real goal is to have access to any information that I need easily and regardless of format. We work with a number of airports that are now receiving 3D BIM as-builts of their new terminal facilities, and they want to be able to create a digital portal of all of their digital data, whether it's CAD, BIM, or GIS. And in that context, they're looking to the GIS as a way of organizing the data, and in some cases converting or transforming the data, but also leaving the data in its native format, but just being able to access the data through the GIS. We've seen great interest among airports, but also increasingly in ports for 3D data, not only of landside facilities, but also subsurface and bathymetric data, in rail agencies as they plan new track alignments, and among highway agencies for bridge and new highway projects. And while 2D designs are often still the official documents for new highway projects, we're beginning to see state DOTs move into 3D design, particularly with the path-breaking work of Wisconsin DOT and others such as Oregon, Utah, Missouri, Massachusetts, Caltrans, and New York State DOT. And in fact, New York City is emerging as a leader in the use of 3, 4, and 5D technology for their transportation projects. And this trend will only accelerate as we gain greater experience with 3D design and construction. The concept relating to the data and the project lifecycle is often referred to as whole lifecycle information management. It really promises to result in significant efficiencies in data and information flow as we move through the infrastructure lifecycle. Currently, the handoffs at different stages of the lifecycle are either non-existent or take place with great loss of data and information. But if we're able to better integrate information from our various software platforms, then we only stand to gain considerable efficiencies through this interoperability. When Europeans often refer to BIM, this is really what they're referring to, this whole lifecycle information management. A number of years ago, the National Institute of Standards and Technologies surveyed a large number of engineering firms, and some of the conclusions were really quite significant in terms of the cost and the time savings that could be achieved if we really had better interoperability between our systems, and if we begin to think about the information flows as we move through the infrastructure lifecycle. So one of the key findings is that if we really took our information and communication very seriously from the beginning of the project, that could actually reduce the project delivery time by 20 to 50% of the project delivery time. And perhaps even more significantly, that if from the very beginning of the project we begin to think about our information and how we were going to manage that information through that life cycle, that we really could save up to 14% of the O&M costs of the project. Well, to the extent that O&M is typically 70% of the total project cost, that's really a quite significant savings that we have the potential to capture by thinking about civil integrated management and whole life cycle information management. Sometimes we at ESRI refer to that as really engineering information systems, and I think that's really the direction that we all need to move. I'd like to reference what I think is really a great example, and this was the largest infrastructure project in the UK. It was Crossrail that was really designing and building a underground rail connectivity project that really went from the west side of London to the far east side. And there is, at the end, there's a link to really a great presentation by Crossrail. But from the very beginning stages of the Crossrail project, they were very clear that they were really building, as they said, two railways, the actual physical railway, but at the same time, they were constructing the 3D virtual railway, and what is sometimes referred to as the digital twin. And so that was really part of their thinking from the very, very beginnings of the project. And I think that they've actually been able to show quite significant savings associated with the project and approaching it in this sort of civil integrated management framework. And they were very clear that really from the beginning of the project, they really needed to think about the sort of the way that they were going to have the 3D and the 3D models, but also what were the data models that increasingly, as the project moved through the life cycle, that those data models were going to have ever greater and greater importance. So very clearly from the early stages of the project, they thought in these terms and how they were going to manage all of the data as they moved through that life cycle. With that, let me turn it over to Don Keeney, who's really going to show you some really great examples, and we'll be able to discuss both where we're going at ESRI and how we're going to support GIS and BIM. So, Don?
Yeah, great. Thank you, Terry. Well, I'm Don Keeney. I'm a 3D product manager at ESRI, and I think Terry did an excellent job of giving us an overview from the industry perspective. As a product manager, I'm really rely on that information in not only the industry of transportation, but really across a lot of the different industries that we support at ESRI. I think transportation specifically is one of those industries that really encapsulate a lot of the requirements that we have to look at as a software company. And so he's presented, this idea of a life cycle management, and one of the goals we have at ESRI is, turning those needs into products. And so, we've done a lot of work looking at, different wheels or diagrams of the types of problems that we're trying to solve. And so Terry's already pointed out that there seems to be a general division of application of different technologies to this life cycle wheel. But as we've been going through this, we recognize that this is not really a static picture. That sometimes is an oversimplification, and that there are potentially more motion involved in this wheel, or combinations of wheels. And so, when we take a look at the life cycle wheel, sometimes we think it's useful to look at them as really concentric wheels or linked wheels, and across the life cycle, looking at what are people actually doing during these phases of a project or the infrastructure life cycle, and how different technologies are being applied to get real work done. And so, kind of looking at definitions of technologies, we have a geographic information system, right, that is good at storing and working with information. And depending on your definition of the acronym BIM, whether building is a noun or a verb or plural, or whether M is a model or management or a system, we can all agree that what's really important when we're working with them together is information, and getting access to information where you need it. And so looking at the life cycle wheels as really a machine that needs to work better together. As Terry pointed out, there are inefficiencies when you can't access the information that you need where you need it. And so really at the highest level, when we look at applying solutions to this space of better interoperability, I think at the highest level, GIS, can inform the BIM process for designers and engineers, getting them the context for the design that they're building. And then once that project or that infrastructure is being built, it then becomes part of that context. It is the existing conditions that new design and redesign and enhancements occur to the built environment. So going from a really sophisticated or simple wheel to a more sophisticated wheel. Why are we talking about this now? Why is this subject so popular in so many of our different industries? Well, one of the reasons is because of technology. So GIS is really a 3D technology. And so Esri continues to develop in the 3D space. And so for the first time, we can really start to work with 3D information, and 3D building and infrastructure is a logical inclusion in the map. And so people are seeing that it's possible. We're not building an architectural design software, but we are wanting to do a good job of working with all different aspects of 3D to simulate the world. So this includes analysis tools and visualization tools across the platform. So giving people access to 3D information, in powerful desktop applications, lightweight desktop applications, web applications, and even mobile applications, but also trying to provide a common experience across those platforms. We've also been developing ways to work with huge amounts of 3D information in a streamable format, so entire cityscapes like these 3D objects, being able to author content and then also serve it out into all the different parts of the platforms and different computing environments. We have another 3D type of data that's common in the collection of drone information, like this information from Bentley's context capture, being streamed out in a web format to the ArcGIS platform. We've also introduced a streamable point cloud format that allows you to work with huge amounts of LiDAR information. In all of these different 3D streamable formats, visual techniques and filtering is being accomplished so that you get more detail in the foreground and less in places where you can't see them. And all of this technology in the background helps us to deal with the complexities of these different data sources and being able to put them all together where people need to see them. So when we take a look at the power of a GIS, we can see certain integration patterns that start to emerge. So we have existing business partners and people systems integrators that are putting together different types of technologies. Like here on the left, business partner Indoor Reality has a backpack that they can use to go through buildings and scan the contents of buildings. And that process develops things like the spherical imagery, but it also is a process that is a scan to BIM process that's also creating representations of the building in 3D. And what they've done here is they've used the GIS as a kind of a navigation tool to pop into one of their viewers to make more sense and organize that content. And on the right-hand side, this is an example where Revit information or information from the BIM modeling and authoring process has been converted into 3D objects in a 3D web scene in the GIS, but there are maintained a hot link back to a storage in Autodesk's BIM 360 to get to one of their viewers. And so you can browse around your campus and see the building content. But then if you want to see more detail, they've created a link that opens up the actual Revit model in a separate window. So the idea that the GIS can be used as a kind of a navigation tool for more information. Another pattern that we see is linking the information of GIS to a design tool. So the existing application from Esri, there's the free plugin ArcGIS for AutoCAD, allows you to be in AutoCAD and access GIS information through services. It also allows you to use the AutoCAD tool as a way to build GIS databases that ArcGIS Desktop can read readily. So both the ability to access web services, but also the ability to generate GIS information using a design tool like plain AutoCAD. Recently, there's been a kind of a big announcement that Esri and Autodesk are working more closely together And one of the first outcomes of that from the Autodesk side is their tool in their InfraWorks product, which has a similar type of connection to the ArcGIS platform in that it allows you to access ArcGIS data inside the InfraWorks application. And one of the benefits of this pattern is that all of the existing applications that work across the GIS can also be leveraged by these design tools. So the same information that may be being collected out in the field in a mobile app like ArcGIS Collector is accessible to people in InfraWorks or into AutoCAD. The same information that's being updated in ArcGIS for AutoCAD is visible in dashboards and web mapping across a GIS system. So what does this pattern look like for ArcGIS for AutoCAD? Well, ArcGIS for AutoCAD is a tool that plugs into plain AutoCAD that allows you to build GIS datasets. And that GIS dataset is completely contained within that file that ArcGIS Desktop can read without conversion. And so in this pattern, you can easily save that information into a native GIS dataset that can then be served out to a GIS enterprise. And all of the different applications and computing environments that can read this data can then make use of that information, including the application ArcGIS for AutoCAD itself that can access that information or any GIS information through services, and even update and edit that information that the rest of the enterprise can then take advantage of. When we start to talk about BIM more specifically, like Terry mentioned, I think in Europe it's really common to think about BIM as an entire digitalization workflow. In other places, BIM can be rendered down to a Revit model or to an IFC file. But when we are taking a look at, what's ESRI going to do about BIM, I think there's, again, some things that quickly emerge. One of the first things that we discover when talking with people is that this definition of BIM, even when you talk about just the data of BIM, can be quite different. There's a big difference between a concept BIM, which is just nothing more than a 3D napkin sketch in some cases that looks really pretty, to a record BIM, which is every single update throughout the entire design process for creating a digital twin. Other people are looking at BIM as a way to do mapping in 3D with attributes. So they may be looking to scan a bunch of buildings and collect attributes that they want to manage, or bridges, or other assets. And so they're really recreating reality, whereas other types of BIM information are very specific, sometimes called trade BIMs or construction BIMs, where there are whole electrical subsystems and structural BIMs that are a model all to themselves. Some of this information may be too dense for GIS applications, but when we take a look at it, we see customers that want to track any and all of this information. So we take that into consideration. So currently, what are we looking at as far as BIM support in GIS? A lot of times what that looks like in today's world is, working through different types of intermediate files like IFC. Being able to export information into IFC, pull it in through a technology like the Data Interoperability Extension or the Feature Manipulation Engine FME from Safe Software, allows us to pull in GIS information or pull in BIM information and make it useful as GIS data. And when we see people doing that, we see them, maybe filing into two different categories of how they want to use BIM information in the GIS. For some people, they want to just see it on a map, and so visualization is really their priority. There's new designs that people are interested in, and they want to share that information with stakeholders, but they want to do it within the context of of the existing conditions, so both the environmental and existing built conditions. And so they want to be able to just access that BIM information as a model and see it in the map. For other people who are interested in doing things like facilities management or construction management or asset management, they really see the BIM model as a container of content that they want to use to build data sets, and they want to query against it, and they want to use their geometries for analysis. And so when we're looking at building solutions, we want to be able to do both of those things. We want to have good representation of the objects in 3D, but we also want to be able to get at the geometry and attributes in a computable way. So one of the first things that ESRI is doing to really dive into this BIM interoperability workflow is to take a look at reading Revit files directly to simplify the path of exporting data to IFC and pulling it in. Although that pathway is still going to be useful for a lot of people, especially those people who are getting BIM information from other sources than Revit, but we see that there is a large Revit community, and being able to read that information is going to greatly simplify people's workflows. So how are we going to go about doing that? Well, currently we read CAD files directly. So the method that we use to read a CAD file is we break it up into a virtual GIS data set. And the way that we do that is by its geometric type. So we directly read all of the points in the drawings and their properties. All the polylines we separate out along with their properties and polygons and annotation. If someone is using the application ArcGIS for AutoCAD, they can build GIS data sets directly. And so if there are any of those explicitly defined GIS data sets, those are read directly as GIS data sets along with their attributes. When we apply the same methodology to a Revit model, we see that a Revit model is more structured than a CAD file, and they are explicitly it has an explicit ontology that says that there are walls and windows and doors, and we can read those directly along with all of their properties. And so we've adopted a strategy where a Revit category equates to an ArcGIS feature class. And with that, we can get a very predictable result from any Revit model that comes our way. We also recognize moving forward that we're going to be generating some very dense and complex information. And so to kind of look ahead, we're also doing work to improve the way we deal with huge amounts of information. So on the left-hand side, this is a kind of a research project where we have this idea of millions of buildings in a city. And what we did is we shrunk down that city and placed it on the roof of just one of the buildings, because we recognize that quickly we're going to need to deal with not just millions of buildings in the city, but people are already asking us to do millions of things in millions of buildings in the city. And although that may be a little way off in the future, that's something that we're working towards. So here's an example of Revit. And in Revit, you have these explicit objects that you can use to create something. You can also add any number of attributes to this information. And so here, I'm just adding an attribute to this roof object and then filling in its value here in Revit. And I can save that information. Now here I am in the soon to be released ArcGIS Pro 2.2, where I can directly look into this Revit model and then add this Revit data directly to my scene. And I see that information, its geometry, as well as the attributes that are stored on that object, I can readily access as GIS features. And even without saving this information to a formal GIS data set, I can use it in analysis or in geoprocessing. And here's a geoprocessing tool that's kind of interesting. It's going to export this GIS data, or in this case, Revit data that is stored or being used in ArcGIS, and export it to a CAD file. I could just as easily have used a geoprocessing tool like Copy Features to save this to a geodatabase, but just for example purposes here, I used another tool that exports it to an AutoCAD file. And because I'm opening this data in ArcGIS for AutoCAD, I'm seeing this 3D information as GIS feature classes, including all of the attribute information that gets carried along with it. So just kind of an interesting byproduct of being able to read Revit models as GIS data. I can use a tool like this one that copies it to a CAD file to convert Revit data to AutoCAD data, but in a smart fashion. Along with this whole subject of BIM, Terry mentioned that other acronyms like CIM, whether that's a civil infrastructure model or a civil information model or a city information model. We realize that there's more infrastructure than just buildings that we need to pay attention and to look to. And so, if you look at kind of the panorama of different AEC design apps that there are in the world, I think when we take a look at what are the things that we can do with Autodesk, some of those other applications in their portfolio would make sense to have better connection, similar to the pattern you might see in ArcGIS for AutoCAD. And then there's also dealing with other types of civil design data. And so these are also things that we're taking a hard look at and how to better integrate. So that's what I had for right now. And I don't know, Terry, if you have some questions that we can answer, or if there's some specific things for me that you'd like to see, I can send it back to you.
Yeah, so thanks, Don. The one actually that really for our roadway, and do you have the one example where the bridge overpass and the side by side of both Pro and of Autodesk? Do you have that one up and running or no?
Sure. Okay. Here's an example. I think Terry had this early on in his slide deck,
Yeah.
As one of those. So this is an example of that pattern where actually one of the distributors in ESRI Germany has built out an application that connects information stored here in a web scene for a bridge that he's added to a web scene that has information about the entire bridge. But also this bridge has a link to BIM 360, and he's done a little coding to create a window into that one file that is the same geometry, from which I can take a look and open up the Autodesk viewer and do things like identify very individual pieces of this thing, and then use this environment to work with the model in a different way, a different level of complexity. And so this idea here is something that you can do today, obviously just pasting really the two technologies together. And because this seems to be so popular, it's also something that we in Autodesk are taking a hard look at, maybe helping this come together more easily for people.
Okay, yeah, thanks. And I've a lot of the early emphasis really of the integration has really been on the BIM on the building side, but I think this is another great example that again, how can we use these technologies in a complementary way? All right, well, let's start with some questions. And so, Don, as you know, there's been considerable interest in the integration of CAD and BIM and GIS, and Actually, Don and I did a series of workshops for airports. That's really where we've seen some of the very early interest. But can you tell me where you see these trends going ultimately? I mean, where are we moving to, and what do you see as the where we'd like to be able to be?
Yeah, I think that that really, yeah, I guess from the high level view, we'd like to be able to remove the barriers to interoperating between the design space and the facilities management, asset management, and GIS space. And so you talked about some of the studies that have been done for the hurdles of interoperability. So really at the first stage, we really want to try to reduce the pain that people have to go through to get information back and forth. And so whether that's a pattern of, making connectors like Autodesk InfraWorks connector to ArcGIS, or ESRI's ArcGIS for AutoCAD to provide the information where it's needed in the different software components. That's one aspect. The other is a more coordinated effort to look at overall workflows and what people are really trying to accomplish, and streamline those as well, so that we get to a point where you have a GIS, which is a kind of a nervous system to a city or a airport or transportation network, and the design tools work together with the GIS to make transactions against that, digital twin. That's another, I guess, way to say it. And then being able to, again, look at the digitalization workflow for both, managing the assets in the world, but also the documentation, whether it's construction documentation or other things that are hanging off of that. And then, obviously providing that information in the appropriate applications and computing environments. And so I think there's a lot of opportunities to make things better. And so, yeah, I guess that's kind of my view of it.
So, and I think, you've briefly covered this, but I think, because my experience is that when people talk about BIM, there's really a huge number of definitions, and I think that I quite often personally think of it really as sort of a design process by which we're really creating a 3D design of the different elements of the design: structural, electrical, HVAC, etc. And those are really brought together. And the great advantage is that you can actually deconflict those designs in such a way that the ultimate design then has a much greater constructability. So there's many fewer sort of change orders, and in fact what's actually designed can for the most part really be built in that way. And yet, in the European case, as we've seen, that as we mentioned, the BIM. So can you really sort of talk about kind of the differences and the problems with the different definitions of BIM, the way that we use them in the industry?
Sure. Well, clearly, I think that the number one reason why BIM is successful is because it works, and it works to save people money and time and aggravation. And the way that it does that is by the application of technology and the digitalization process that makes things computable for those things like scheduling and conflict resolution. Overall, BIM has proven that it reduces uncertainty, and that reduction in uncertainty, improves safety. It reduces the time that things require to be constructed. It makes less problems, because a lot of times these things have been virtually constructed already. There's less time searching for documents, because there's a definition of how documents should be packaged and handed off from one stage to another. So that digitalization process is a proven method of reducing uncertainty. Well, clearly making access to more context in the geographic sense will further reduce that. You have something to add, Terry?
Yeah, no, I just, again, I sometimes think it's useful to, when having a discussion about BIM, to really define what it is that we mean. And unfortunately,
Yeah,
there are so many different meanings of the term that I think sometimes it can create conversations that really don't that aren't effective, because we have
right,
different conceptions, and I just
right.
I think it's a
Yeah,
problem in the.
yeah, sure. And so, I mean, if I take a look at the definition that I'm working with on a daily basis, I've really, in my mind, a lot of times reduced the term BIM to a building information model, because that's data that I can work with. And I see it in the context of the larger digitalization workflow. And certainly there are aspects of scheduling and asset management and other technologies that they're all kind of tied up in this thing. But at the same time, I work for a GIS software company, and so at the very beginning, I have to provide basic fundamental technology to reduce the workflow or the work that's required to integrate things. And so, as a working definition on a daily basis, I look at BIM as data, and so I distinguish, BIM from CAD, but really you could fold CAD data into the BIM digitalization overarching workflow, and that fits just fine. But when I have to build a CAD integration tool, I do recognize that they're different than the authoring tools of BIM, like ArchiCAD or Revit or Bentley Architecture or any number of other BIM authoring tools. So, sometimes we talk about the European definition of BIM versus the US or North American version of BIM. Sometimes you can reduce BIM in the US to Revit. Sometimes that's maybe a little bit too narrow. Sometimes in certain parts of Europe, you can say that BIM equals IFC. And so we recognize that all of these things are out there. And so as we move forward, with working definitions, we do want to solve real problems that people have access to. I don't know if that helps.
Yeah, thanks. And before we get to some of the more very specific, can you really kind of talk about where we are with the relationship with Autodesk, what you're really working on, what are the integration points, and kind of maybe a little bit of a timeline on that as well?
Sure. I can really only speak for a timeline on the ESRI side of things. Autodesk, although we have very similar goals, we have different corporate structures, and so Autodesk being a publicly traded company, they can't really talk about futures too much, except for in the quarter that things are going to be released. And so along those lines, one of the things that has been worked on the Autodesk side is that cooperation with ESRI to help them get a connector to InfraWorks, working directly with them to assist them in putting together that technology. From the ESRI side of things, an emphasis on working more closely with Revit data is one of the first things that's coming out on the ESRI side. We've kind of put that together. That was something that was in the works before this, but it's being accelerated because of the interest in BIM. If you look at the portfolio of Autodesk products and look at where people need problems solved that are similar to that of InfraWorks, I think it's not too far of a stretch to think that, yeah, that might be a good idea. Other things that we're working on is we recognize that there's, one of the important factors that we need to work on more closely together is coordinate systems. And so we currently have different methods of defining coordinate systems. So there's talk about how we can better, organize and reposition data and just define where things are. So we're really looking at the entire workflow and different ways that we can put things together. But at the same time, to kind of manage expectations, I think my manager talks about this. Chris Andrews, he talks about how we've been working on just talking about working together for 2 years, and so it's not something that in a short time frame we can solve all of the world's problems, but we are very interested and motivated to make things better moving forward.
Yeah, and along that line, there was a question really relating to Bentley, whether we would actually be able to bring in 3D roadway data from Bentley into ArcScene, or I guess more appropriate, ArcGIS Pro. Can you speak to that?
Yeah, so yeah, this is certainly not an exclusive type of a deal. So working with Bentley, we've been working with Bentley on the 3D side of things with their context capture application to help move 3D information collected there into our streamable format. So for mesh data, roadway information is certainly something that is valuable for us to pull in. We have access to technology from Safe Software in our data interoperability extension that can help move that forward. And so, we're open to any of the design tools that want to improve interoperability. So specifically with 3D road data, if there's an IFC export, we can certainly access information that way. We do support the DGN file format directly. Are there things that we could do to improve that? I think so, yes. And so we're open to improving those things.
Yeah, I think there are probably a number of questions really relating to not only IFC, there's what kind of data interoperability is on the roadmap for IFC bridge, roads, and alignment files, but also even sort of working with GML and infra GML and really looking at open data standards. So can you speak sort of more broadly to those trends as well?
Yeah, sure. So I think that when we looked out at the horizon of BIM in the center of BIM, a lot of it was architectural. And so if you took a look at the largest segment of that market, it kind of points us to Revit. Looking more generally, IFC certainly is pervasive throughout the world and is enlarging its footprint for things beyond just architectural buildings. So you mentioned things like roadway alignments, and I hear there's work being done in airports for specific types of airport information, and we certainly will be monitoring that closely. As far as some of the other GML formats, we would probably lean a little bit on Safe Software and FME and the data interoperability extension to pull out some of those formats in the short term. But if there is a prominence in one data type over another, then we can take a look at that as something that we directly read. I would say probably IFC is closer to something that we would take a look at than GML.
Okay. There's a question, could you shed some light on tracking of the different versions of data and BIM in the life cycle? And I guess the person sort of mentions that that's really sort of a monumental task on its own.
Oh, sure. Yeah, and so I think that, so for the dealing with revisions of files and things of that nature, the workflow for pulling in BIM information into a GIS is either something that you do in the moment, or it's something that you publish to, and then there's the problem of keeping it in sync. And so that is a monumental problem if you're trying to update both simultaneously. It's not the first problem that we're going to solve, but there are techniques that you can do to code in version information as attributes and and solve it through workflows. And so there's no silver bullet in the next release that's going to help you do that.
Yeah.
It's certainly something that, in long-term plans that we recognize as very important, but it's also one of the more difficult things to do.
Okay, there's a question about where's the imported Autodesk data being stored in ArcGIS? As a file geodatabase? Is it
Sure. So when you open up a Revit model, and we're talking about specifically in ArcGIS Pro 2.2, when you open up a Revit model, it's going to load that information into memory as GIS 3D features. That's going to equate to, in ESRI terms, it's a data type called a multi-patch. That multi-patch information could then be saved directly to a file, either to a shapefile. There's a multi-patch version of shapefile, a file geodatabase, or enterprise. And so all of the different incarnations or flavors of a geodatabase, even a shapefile, can support this Revit information. And you also saw that I could export that data as mesh or multi-patch data into AutoCAD along with its attributes. So where's that data stored? It's stored wherever you want to store it, or you can just read it in memory and not convert it.
okay? There's a question, and I guess I use the term 4D and 5D. Sometimes I even hear 6 and 7D now. So
I think my slide had 8D.
yeah, so I'll just clarify. 4 and 5 typically refer to cost and sequencing. So I did mention the New York City. Actually, what they have done is that for each of their major transportation projects, they've actually moved those projects really into 3D, and then the ability to add the costing and the sequencing actually allows you to see the sequence of literally each piece of each stage of the project as it's being built. And typically, if you have a roadway or large bridge or some combination of the two, these really are, sort of they span over multiple years, and so you literally can actually see the sequencing of that. And so I would encourage you to take a look. There's a number of, I think, videos on the web that you can actually see how that both 3, 4, 5, and I lose track of beyond 5 myself, so I think there's sort of validity is one or so. I don't know, but anyway. So where so we've already talked about airports and ports. Can you really sort of discuss the possibilities that you see for highway and bridge data? And I guess there was also a question about tollways that when you finish, I'll actually answer that one as well.
Mm-hmm. Well, yeah, certainly any 3D information, independent of where it's sourced from, is something that you could incorporate into the GIS. It becomes more complicated when you start talking about these things as part of a network, and so there's a point at which we need to I don't know, not skeletonize, but abstract certain things into networks. But other times we're really just talking about the 3D objects and how they look and how they fit into the environment, whether that's manipulating the terrain or talking about other aspects of how they work together. There certainly are people who build bridges with Revit, but there are certainly other authoring tools that can be used to do bridges. So for those that are in Revit, those will be automatically included. Past that, we're really open to listen to the customer and what they need to see. IFC is obviously another path that is available now that could potentially also be improved in the future.
Okay, and sort of to the question on tollways, I think we are beginning to see that level of interest. Certainly, we've worked with a number of tollways in the European case, and I think certainly it makes a great deal of sense in the context of a new project, a new 3P project that will end up being a tollway. Literally the ability to do the design and then really sort of pass that over into the GIS for operations and maintenance, I think will over time kind of become the emerging standard. I guess, you know, so again, we probably see it a little bit more in the context of the European case, but we anticipate that we would see that as well, increasingly in the US. Don, I think there's a question or two really having to do with can you talk about, you know, how when you connect to the Revit model, how do you subset the data that actually gets extracted? And then there's also, I think, some performance. There was a question about really sort of performance as well in terms of these connections. Does that really sort of slow down the performance on both sides, if you will?
Sure. Yeah, those are excellent questions. The first one is how do we slice up a Revit model to view it as GIS data? And the answer to that was on one of the slides, is that in Revit there are a discrete number of categories: walls, windows, doors, floors, ceilings, pipes. These categories we are going to treat as a separate 3D feature class. So there'll be a walls feature class, there'll be a ceilings feature class, there'll be a doors feature class. So we're equating a Revit category with an ArcGIS feature class, and then collecting the attributes for those in a virtual GIS data set. Now, as far as performance is concerned, that's a great question. So, you know, there can potentially be huge amounts of information in any one single Revit model, and then we start to try to bring multiple models together. Yeah, you're going to take a hit for first opening up the data, and that's pretty much the first hit. So for any of those people who have actually worked with Revit, and you know, the process of scanning a model to load it is going to be similar to when you have to upgrade a model from one version of Revit to the next. So it can take up to a couple minutes for a medium-sized model to be pulled into ArcGIS. But once it's in memory, it's pretty quick and slick. If you want to deal with multiple models together, it's probably best to convert those into a geodatabase, even temporarily, to deal with the graphics load that's going to be on the system. When the information's in memory, it has certain disadvantages in performance. So when I work with maybe more than two models, I'll convert them even temporarily to a geodatabase, which is pretty easy because I can just say, you know, copy these into a geodatabase. And if I have to load up the model again, it's going to be higher performant if it's stored in a geodatabase. And what is the geodatabase that gets created? It's essentially multi-patch feature classes that are the walls, windows, doors, floors, ceilings, and walls.
Okay, and just briefly in the sort of remaining minute that we have, where do you see the industry standards going with respect to BIM and civil integrated modeling and IFC?
Well, certainly IFC has come about partly because of poor interoperability between the authoring tools and the GIS, and so and all the applications that need to use BIM information. So in some ways, seeing what's actually in a Revit model may suffice for a lot of people, but the requirements of interoperability go beyond just GIS, and so I see that IFC will continue to expand to include more objects and things, and ESRI will pace along with it.
All right, well, let me, and again, as I mentioned, these slides will be available on the GeoNet Departments of Transportation website. We would encourage you, for those of you that are interested, we have the AEC Summit at the UC. Don mentioned the ArcGIS for AutoCAD plugin. We have a couple of great examples. As I mentioned, there's a great presentation by Crossrail. There's another one on planning light rail in 3D in the Austin case. And then really an introduction from our 3D team, an introduction to 3D and GIS. So I would encourage you all to take a look at those, and we'd like to thank you for attending today. And Don, I'd like to thank you for being a part of the webinar today. And with that, we'll close it off, and thanks again.